For more than 60 years, NASA and other space agencies have sent some of humanity's best and brightest into space. Not just doctors and PhD scientists, but also national cycling champions and microgravity marathon runners. So thanks to all those astronauts, we know what space does to a human body in peak physical condition. But what about the rest of us? How does space affect someone whose greatest endurance achievement is a lot closer to marathoning every episode of Avatar: The Last Airbender in a weekend? Well, due to the enormous cost of space travel and strict astronaut selection processes, researching that question has been a non-starter. Until very recently. In 2021, 4 civilians spent 3 days in Earth's orbit, crammed into a spacecraft cabin the size of a cargo van. This was the Inspiration 4 mission, and the research papers on what happened to its crew are finally starting to trickle in. So let's see how space affected their bodies and what this mission taught us about the future of space travel. As commercial space travel grows in popularity, more civilians will go to space. And if you're trying to study the effects of human spaceflight, those extra bodies are a good thing in more ways than one. Not only do they give us a view into how a quote-unquote average body handles space travel, but they also increase the overall sample size of space travelers. And more data is always useful. And even if the profile of your typical NASA astronaut doesn't change anytime soon, civilian missions do benefit NASA too, because before sending anyone to Mars, they still need to answer a lot of open questions about long-term space travel. Like, how will NASA monitor those astronauts' health? And what medical tests can astronauts reliably conduct on each other so far away from the rest of humanity? Researching those questions is much easier with civilians than it is with professional astronauts, because the pros are in short supply and take at least 3 or 4 years to train. So the Inspiration 4 mission gave scientists, like the ones at the Translational Research Institute for Space Health, or TRISH, an opportunity to answer some of these questions. Each crew member wore an Apple Watch to passively record a variety of physiological metrics, like their pulse, physical activity, and the amount of oxygen in their blood. They also had an iPad to take surveys about their mood and complete cognitive tests like NASA astronauts do on the International Space Station. As for more sciencey looking equipment, the crew used portable, miniaturized ultrasound machines connected to a smartphone. This allowed them to collect scans of each other's eyes, bladders, and neck veins, and look for indicators of common astronaut health problems. And finally, to see how their immune systems fared, they had to collect blood samples, skin swabs, and more. Some were like the ones that you'd get at an annual physical, and others were a bit more niche. Now, all of these measurements were also taken on Earth, both before the crew launched and after they got back. And in these 2 cases, the astronauts didn't do all the poking and prodding, actual experts did it for them. By comparing the in-flight data against the pre- and post-flight data, researchers could compensate for the study's incredibly small sample size of 4 whole people and get results that were at least a bit more rigorous. Now, science takes time, so even though Inspiration 4 happened way back in 2021, the first round of research wasn't published until 2024. So now we're here to break down some of the results. First, and most importantly, the 4 civilian astronauts did not experience any serious health problems during or after the mission. This suggests that short-term space travel doesn't pose a significant risk to everyday people, which still does not make me want to go to space, but I'm happy for all of you who do. And in one case, there was a pleasant surprise compared to the known effects of long-term missions. Astronauts on multi-month trips are prone to develop blood clots, but scans of the 4 astronauts' jugular veins revealed no abnormalities in their blood flow, so at the very least, clots may be less of a concern if you're only going up there for a few days. The next result was a promising update on scientists' hunt to explain why a lot of astronauts get motion sickness in space. We've covered the topic in a previous episode, so you can check that out for more info. But in Inspiration 4's case, scientists wanted to test if we can actually predict if an astronaut will get space sick ahead of time. And one of the ways they did that was by scanning their eyes. Now, eyes might not be an absolutely necessary organ for a human to navigate the world, but they sure are handy. They help tell us how we're oriented in space. Here's up and here's down, and they help us know when we're moving or if our orientation to our idea of up and down have changed. But for many people, their eyes aren't symmetrical, specifically how they're aligned when you're looking at something. On Earth, this asymmetry doesn't really matter. Our bodies have developed with a clear sense of up and down thanks to the planet's gravity. But the microgravity environment of a spaceship zooming around the planet or off into the wild black yonder is a completely alien experience. So researchers have hypothesized that when astronauts go to space, we lose that sense of up and down down, and the usual directional cues we get on Earth might not help our brains fix the problems. This might be the cause of space motion sickness. And tests for Inspiration 4 showed that 2 of the astronauts had a consistent change in the way their eyes were aligned before and after the flight. These were the same 2 people who didn't get motion sick when they were in space, which suggests that their ocular alignment shifted to compensate for microgravity. So if more research continues to show the same results, space agencies could start using this kind of eye scan to screen astronaut candidates. If not to weed out people for certain missions, then at least to send them up with our best anti-nausea medications. Motion sickness wasn't the only thing that Inspiration 4 collected data for, though. The mission also showed that everyday bodies experience a few well-known changes that happen to those of professional astronauts as well. For example, your telomeres, the protective caps at the end of your chromosomes, they get longer in space, but they rapidly shorten after you get back. This means that space travel may make your DNA more vulnerable to mutation. And then there's the rather disturbing fact that space can reactivate viruses laying dormant in your body, like the ones that cause mono and chickenpox. Previous research had revealed that the longer astronauts are in space, the more virus they shed, making them more likely to infect their crewmates. And while astronauts' infections have generally been asymptomatic, a reactivated virus can be life-threatening. And that's a problem for both civilian and NASA astronauts, and we don't have a solution for it yet. So let's move on to a result that differs between the 2 populations. Inspiration 4's civilian astronauts were slower and less accurate on the same cognitive tests that NASA astronauts take while in space. Although, good news, they did return to normal performance after they got back to Earth. Declines like these are typically seen on the International Space Station when astronauts don't get enough sleep, but the civilian astronauts seem to sleep plenty. They actually slept longer than most do in space. So while the cause of these cognitive declines is unclear, researchers speculate that they might actually be happening to astronauts on the ISS too, just without us knowing about it. The first couple of days on the ISS are jam-packed, and NASA typically doesn't get cognitive data until a few days later. But on Inspiration 4, the crew started taking these tests right away, suggesting that these declines could be just a normal result of humans adapting to microgravity. And if that's true, we would expect to see civilian astronauts return to baseline after 4 or 5 days in space. And finally, let's end on what might be the most impactful result for future spaceflight. All of the measurements the Inspiration 4 crew took of each other, except those from the most technical eye exam, were totally usable by researchers back on the ground. And that's in spite of the fact that these civilian astronauts received no real-time guidance when testing each other. That is, and I can't stress this enough, not at all how it works for the professionals. On the ISS, astronauts use traditional devices you'd find in a doctor's office, not handheld, iPhone-controlled ultrasounds. And professional astronauts have a staff of experts on Earth guiding them through a procedure every step of the way. But Trish scientists had a method to this research madness. When we send astronauts to Mars, there will be up to a 23-minute time delay for communications each way, and that makes real-time instructions completely impractical. Astronauts on long-term spaceflight missions will need to take measurements on their own. So, by testing whether a minimally trained civilian crew could collect usable data using portable ultrasounds, Trish could shed light on how to monitor the health of astronauts on long-term space missions, and what procedures will require more in-depth training. Inspiration 4 kickstarted a new era of civilian space travel, and taught us that civilians are up to the task of navigating the stars. And on September 10th, 2024, the second all-civilian space mission launched, Polaris Dawn. One goal for that mission was to study how space radiation affects human health. And to do that, the crew flew through one of Earth's radiation belts, and 2 of them, including Jared Isaacman, who led both missions, became the first civilians to go outside their spacecraft. All 4 astronauts returned safely to Earth 5 days later, with loads more data for Trish to dig into. And right now, there are 2 more Polaris program missions scheduled, and with each one, we'll get that much closer to answering the big questions about how space affects everyday people. Like, how much do I have to worry about getting chickenpox again and infecting my crewmates? Although, if I was stuck in quarantine up there, I could pass the time by marathoning Avatar again. Support for this episode was contributed by the Translational Research Institute for Space Health at Baylor College of Medicine. Trish is an applied health research catalyst that funds high-impact scientific studies and technologies to keep astronauts healthy during deep space exploration. Trish is empowered by the NASA Human Research Program and a consortium led by Baylor College of Medicine with partners MIT and Caltech.